Hi, Assalamualaikum warahmatullahi wabarakatuh, and hello to everyone who is watching this video. My name is Muhammad Shukri Muhammad Suib, and I'm from class AS120, Diploma Science, class A. And today I'm going to present about one element that is very common for us, that is found in our air, and is very useful for us. So today I'm going to talk and explain about nitrogen. So let's start. So the topics that we are going to discuss about nitrogen is first, the unique physical properties and chemical properties, second, the electronic configuration, third, chemical bonds, and fourth, daily life or industrial application of nitrogen. So here is that. So first thing first, the introduction of nitrogen gas. It was first discovered and isolated by Scottish physician Daniel Rutherford in 1772. English word nitrogen entered the language in 1974. Nitrogen gas is a chemical compound with symbol N with a small 2, N2. Next, dinitrogen forms about 78% of Earth's atmosphere, making it the most abundant uncombined element. Nitrogen occurs in all organisms, primarily in amino acids, proteins, chlorophyll, in the nucleic acid, which is DNA and RNA, and other biomolecules. The human body contains about 3% nitrogen by mass. It is so inert and at standard temperature and pressure that was termed azote, meaning without life. So nitrogen with the symbol N and the atomic number is 7. The atomic mass is 14.007 and it is located at group 15 and period 2 in periodic table. So the structure of nitrogen gas. It is extremely strong triple bond in elemental nitrogen, which is representing by N and the triple bond with N. It is the second strongest bond in any diatomic molecule after carbon monoxide. So now we will see the Bohr model of nitrogen. So we can see the nucleus is in the middle, is at the center, and at the first shell there are two electrons at the first shell, and at the second shell there is 5 electrons at the second shell, which makes it has 5 valence electron. Moving on to the physical properties of nitrogen. Nitrogen physical properties is it is a relatively inert gas. It is colorless, odorless, and tasteless. Liquid nitrogen is also colorless and odorless, and it is similar to water. There are two allotropic forms of solid nitrogen, A and B, with a transition between the two forms at negative 237 degrees Celsius. And the density is 1.25 times 10 to the power of negative 3 grams centimeter negative 3 at 20 degrees Celsius. The melting point is at negative 210 degrees Celsius. And last but not least, the boiling point is at negative 195 degree 195.8 degrees Celsius. Next is nitrogen chemical properties. Nitrogen chemical properties is nitrogen form compound through biological activity at high temperature or at moderate temperature with the aid of catalysts. It forms nitric oxide and nitrogen dioxide with oxygen, ammonia with hydrogen, and nitrogen sulfide with sulfur. At high temperatures, it will combine with certain active metals such as lithium, magnesium, and titanium to form nitrides. It is non-flammable and will not support combustion. The energy of first ionization is 1402 kilogram joule per mole. Energy of second ionization is 2856 kilojoule per mole, and energy of third ionization is 4577 kilojoule kilojoule per mole. And last but not least, electronegativity according to Pauling is 3.0. Next, reactive metals like magnesium, calcium, aluminum, and other reactive metals, when burned in nitrogen, forms respective nitrides. As shown below, magnesium plus nitrogen, it will form magnesium nitride with heat, and calcium react with nitrogen, it will form calcium nitride with heat, and last, aluminum reacts with nitrogen, it will form aluminum nitride with heat. Next is the chemical bond of nitrogen. First, we have formation of a nitrogen molecule. We can see nitrogen atom, it will share 3 electrons with another nitrogen atom, and it will share 6 electrons that will complete the reaction. So we can see the diagram shown. Next, we have the formation of nitric acid. Nitrogen, it will react with oxygen and it will form nitric oxide, and nitric oxide, when it react with oxygen again, it will form nitrogen dioxide. Moving on to electron configuration of nitrogen. The electron configuration of nitrogen is 1s1, 1s2, 2s2, and 2p3. The p orbitals are half filled because there are 3 electrons and 3 p orbitals. This is because the 3 electrons in the 2p subshell will fill all the empty orbitals first before pairing with electrons in them. Moving on to the daily life or industrial application of nitrogen. First, we have a Haber process. Nitrogen is used in Haber process to produce ammonia. Ammonia is very important to produce nitric acid, fertilizer, pharmaceutical products, and explosive. Second, it is also used to modify the atmosphere packaging of foods to make the food last longer, looks better, keeps the taste, and allow transportation, and it helps slow down bacterial growth and other spoilage mechanism. If nitrogen is not used in modified atmosphere packaging, it will bring spoilage to the foods. Next, we have liquid nitrogen. Liquid nitrogen, as we all know, it is very cold. So it is very useful in medical uses. It is also used to preserve biological specimens such as blood and tissue samples. Now here are the list of the uses of nitrogen in our daily life and industrial application. So that is all from me. I hope you get a lot of information from here, and thanks and enjoy.